In this video, we're going to walk through an example of deciding if a precipitate will form given the concentrations of the things we are mixing together. So in this case, we're mixing lead nitrate and sodium bromide. Now, if we were to bring these together, we know they're both aqueous. So Pb NO32, our sodium bromide. Again, these are. So the way we predict our products, again, is we just swap our ions. Our lead will form a bond with our bromine. There'll need to be two of them to balance out that +2 charge, meaning we'll have 2 sodium bromide that are going to participate in this reaction. And that'll leave us with 2 sodium nitrates, but those will be aqueous. And we can check that by checking the solubility products of each of these. The sodium nitrate is soluble in water, and so it's a very large K value. But our lead bromide has a KSP, or a solubility product, equal to 4.6 times 10 to the -6. That's small. So that means it's going to be fairly insoluble in water, and we'll expect a precipitate to form at certain concentrations. And we're not sure if we're at the concentration of our ions where that precipitate will actually form, if we're at that KSP. So we do have information about the concentrations of each of these, and we can use that information to calculate Q. So let's look at our lead bromide solubility equation. We'll have solid as our reactants, and then lead +2. Sorry, there's 2 bromine. And 2 bromine. Some faces on that. So using this, we could calculate our Q. That would be equal to the concentration of our lead +2 times our bromine concentration squared. And we're told we have 0.015 molar of our lead concentration, or our lead nitrate, and we have 0.035 molar of our sodium bromide. So our lead is going to be 0.015 molar that we have around, and the concentration of our bromine that we're going to have is going to be that 0.035 molar. And that's just coming from our problem. This is the given information that we actually have with the problem. At this point, I'm just going to plug my values into the Q expression that I already made. So my Q is going to be equal to 0.015 molar times my 0.035 molar squared. And when I plug that value, plug that into my calculator, I'm going to get a value that's 1.84 times 10 to the -7. Sorry, -5. Misread my own handwriting. All right. Now that I have that piece of information, my job is to compare it to my KSP. So my solubility product was 4.6 times 10 to the -6. That means that my Q value is greater than my solubility product. It's a larger number because that exponent right here is a smaller negative number. So with a Q greater than a solubility product, I would predict that a precipitate would form when I combine these together.